Now, in this video, we are going to take up one more problem on projections of laminas. How to analyze this problem in 3D and solve it by using a manual sketchbook. The problem reads as a mirror 30 mm by 40 mm is inclined to the wall such that its front view is a square of 30 mm. The longer side of the mirror appear perpendicular to both HP and VP and find the inclination of the mirror with the wall. So to do that, first we will going to take the initial position. How to take the initial position? So since he says a mirror of 30 by 40, so obviously it should be a rectangle. So where to place the rectangle, whether you have to place it in the front view or either you have to place it in the top view. Since he says the mirror is inclined to a wall, wall means what? It is a vertical plane, and whereas ground means horizontal plane. So here, since he says when the mirror is inclined to wall means what? It is inclined to VP. So since it is inclined to VP, therefore, if you want to make it inclined to VP, first I have to make it parallel to VP. When you will going to make, so that means the inclination of the mirror with respect to the wall will be 0 degree. So how it is possible? Only by keeping the rectangle in the front view. As you look from the top view, all the sides are parallel to VP. Since all the sides are parallel to VP, so you are getting the true length in the vertical plane. So obviously we need to start the problem from the front view. So here you can see the surface of the rectangular lamina or the surface of the mirror is parallel to VP and perpendicular to HP. Since it is parallel to VP, so you are getting the true shape in VP, and since it is perpendicular to HP, therefore you are getting a line in the horizontal plane. As you look from the front view, ABCD is visible, therefore the image will going to fall on the vertical plane, which is A dash, B dash, C dash, D dash. Then this will going to be 40 and this will going to be 30. So as you look from the top view, since it is perpendicular to HP, so you are getting a line. So as you look from the top view, AB is near to the observer, so AB is visible, and C and D is away from the observer, so it will be in bracket. So this is how you will be able to analyze the initial position of the mirror. So here, what is the position of this mirror with respect to both HP and VP? The mirror is parallel to VP and perpendicular to HP. Therefore, since it is a perpendicular to HP, you are getting a line in the horizontal plane. Since it is parallel to VP, so you are getting the true shape in the vertical plane when you look from the front view. So how to write this in orthographic view? That is in the sketchbook. First, we are going to draw the XY line and we mark VP and HP. So since we have to start the problem from vertical plane, you take any distance and from there you measure a distance of 30 and then 40 and then complete the rectangle with a dot line and you mark them as A dash, B dash, C dash, D dash and show the dimension of 30 and 40. So you take some distance in front of VP and draw a horizontal line and draw a vertical projector from A dash and D dash to the top view, and similarly draw a vertical projector from B dash, C dash to the top view. And these two lines will going to intersect at these 2 points and you mark them as you look from the top view. AB is near to the observer, so AB is visible. C dash and D dash is away from the observer, so C and D will be bracket. So this is how you will be able to write the initial position of the rectangular lamina, or it is a mirror. Then what he says, the longer side of the mirror is inclined to the, or the longer side of the mirror appears to be perpendicular to both HP and VP. And in the second position, the mirror is being rotated such that its front view becomes a square of 30 mm. So this side is a square of 30 mm and this side is 40. This line 40 has to become 30. So till such time you rotate this AB in the space. So that is what we have shown here. As we rotate this AB, so you can see that the length of A dash, B dash, which was 40, is start decreasing. Till what distance it will going to decrease? Till it becomes 30. So once you get 30 here and also 30 here, so obviously it should stop that particular point. But AD is parallel to VP, so you are getting the true length directly here. Since AB is inclined, you will not be able to get the true length here. It will be less than the true length. But what should be that distance? Because he has not shown the angle. So you take 30 mm here and complete the square. So when you are making this line as 30, so when you project this and as you rotate in this space, what happens? This line you can observe here, that line is getting rotated. So that means the length of this will going to be the length of this. Once you get this, as you look from the top view, AB is near to the observer, so AB is visible, and D and C is away from the observer, you will be invisible. So as you look from the front view, A dash, B dash, C dash, D dash is visible. So this will going to be a square. This is already 30 and this AB will going to become 30 when this space is being rotated in space. So this is how you will be able to analyze the top view and front view in the second position. What is the surface in the second position? The surface of the mirror is inclined to the wall. So that means the surface is inclined to VP, still perpendicular to HP. Since it is perpendicular to HP, therefore you are getting a line in the top view. So how to solve this in second position? How to draw this? Draw a horizontal projector from A dash and B dash to the second position, and similarly D dash and C dash, draw a horizontal projector. And you take any convenient distance between these two and draw a vertical line which will going to be A dash and D dash, because whatever the line you have here, the same length is going to be maintained. Once it becomes 30, so obviously A dash B dash should also be equal to 30, because that is the longer side, which is 40 mm. So the top view is being rotated till A dash B dash becomes 30. So that means, but since I don't know this angle, so you complete the square of 30 mm side and you mark this as A dash, B dash, C dash and D dash, and you show the emission of square 30. And draw a vertical projector from both A dash and D dash, and draw a horizontal projector from A and D. Both these two lines will going to intersect at this point. You mark this as A and D in bracket. Now similarly, you draw a vertical projector from both from B dash and C dash to the top view, and you measure the distance from A to B by using the compass, and you transfer from this point A onto this vertical projector which was drawn, and then join A to B with a dotted line. You mark them as B, B and C in bracket. So by using the protractor with reference to this horizontal line, you measure this particular angle, which is the surface of the mirror is inclined to the wall, means it is inclined to VP. Since it is inclined to VP, the inclination can be seen in the horizontal plane. So that is why you have got phi. So by using the protractor, keeping at the point of A, you measure the angle which will going to be 41.41 will going to be the answer for a mirror inclined to a wall. So once you do that, then after that you need to rotate. How to rotate this? Because is the longer side of the mirror appear perpendicular to both HP and VP. Why he says appear perpendicular to both HP and VP? Because once the line is perpendicular in one plane, in another plane it should be parallel. If it is parallel and perpendicular to VP, so in VP you must get a point. Similarly, if it is perpendicular to VP and inclined to HP, so then what happens? Since it is inclined to HP and it should be parallel to HP in the, then only it will going to be perpendicular. But here what happens? Once it becomes to perpendicular to VP, you must get a vertical, you get a point in the vertical plane. If it is parallel and inclined to, if it is parallel to HP and perpendicular to VP, then in VP you must get a point. If it is parallel to VP and perpendicular to HP, so then in HP you must get a point. But here in this case, the longer side of the mirror, A dash B dash, is perpendicular to perpendicular to HP. So if you want this to be perpendicular to HP, At second position front view, A dash B dash is parallel to HP. So you need to make that line perpendicular. How I can make that line perpendicular? By rotating this square by an angle of 30 either in the clockwise direction or in the counterclockwise direction. But in this case, I have rotated that in clockwise direction. So A dash, B dash, C dash, B dash, C dash, C dash, D dash and D dash, A dash, which will go to be a square. So that means I am rotating this square like this to get this front view. As you rotate this, as you view from the front view, A, B, C, D, this image will going to be falls on the vertical plane. You can see that A dash, B dash is perpendicular to HP. If it is perpendicular to HP, then it must be parallel to VP. But here, it is not like that. It is perpendicular to HP, and also you can see that it is perpendicular to VP. So, but actually this AB is not perpendicular because it is inclined here. So that is the reason why he says it is appear perpendicular to both HP and VP. So as you look from the top view, the image what you will going to get will going to fall on the horizontal plane. So this is A, B, C, D and join this. So that AB is perpendicular to VP and A dash B dash is perpendicular to HP. If it is perpendicular to HP, then obviously it should be parallel to VP. If it is perpendicular to VP, obviously it should be parallel to HP. But in these two cases, here longer edge will be a vertical line in the front view and also a vertical line in the top view. So therefore, it will not be perpendicular. Instead, that AB line will going to be inclined. So this is how you will be able to analyze this mirror problem. Once you do that, now I need to write the how to write it in orthographic view. So here A dash B dash is parallel to HP, so you make it perpendicular. So that means either you can rotate it in counterclockwise direction or you can rotate it in clockwise. Normally we will going to take it is in clockwise. So therefore you are rewriting the same square of 30 mm by rotating by an angle of 90 degrees. So what does it happens? The horizontal line has to become vertical. So A dash B dash is horizontal here, so that will going to become vertical. Then complete the square of C dash D dash. So once you do that, you need to write the top view, draw a vertical projector from A dash and B dash to the top view, and draw a horizontal projector from A and B. Both these two lines will going to intersect at these 2 points. You mark that point as B and you mark this point as A. Similarly, draw a vertical projector from C dash and D dash and draw a horizontal projector from C and D. Both these two lines will going to intersect at these 2 points. So you mark that point as C and D. So here, how do I know that my problem is right? The longer side of the mirror, A dash B dash is perpendicular to HP and it is also perpendicular to VP. Since in any circumstances, the sides will never be perpendicular to each other. In other words, if the line is perpendicular to one plane, in the other plane it will be parallel. If the line is perpendicular to HP, if the line is perpendicular to HP, then it should be parallel to VP. So in VP, you will going to get if now it is perpendicular to HP, so it should be parallel to VP. So that means in HP you must get a point. Similarly, it is perpendicular to VP. Since it is perpendicular to VP and parallel to HP, so in HP you must get a point. So, but it is not so here. In this case, it is perpendicular to HP and it is also perpendicular to VP. But since this condition will never be possible because it can never be perpendicular to both HP and VP. In other words, if it is perpendicular to one plane, obviously it should be, in other plane it should be parallel. So that means it should become a point. But since here this is also a vertical line and this is also a vertical line, though obviously that line will be actually it is inclined. So but it is appearing like perpendicular to both HP and VP. Therefore it says appears. then then you mark the points as A, B, C and D, and then complete the square. Join A to B, B to C, C to D and D to A with a dark line. So, and we mark this point as Y. So, by using the protractor with reference to this horizontal line, you measure AB length. With respect to the horizontal, you measure the angle of this AB line with respect to the horizontal. Then the angle will be 41 degrees when you are doing it in manual. When you are doing it in computer, you will going to get the exact value as 41.41 degree. This is how you will be able to analyze the problem of mirror problem in 3 dimension, and also I can be able to write by using the sketchbook. Thank you.